Hey guys, today we're going to take a look at the cool new library created by Google called TensorFlow.JS. As the name suggests, the library can be used using just JavaScript, and it can be run in the browser or in Node.js. We're going to use this library today to create a model that tries to predict the next Fibonacci number, that is a number that is from the Fibonacci sequence, given some previous number x. Okay, so for those of you who don't know or have never heard of what a Fibonacci number is, let's take a look at the Wikipedia entry. And the entry suggests that in mathematics, the Fibonacci numbers are the numbers in the following integer sequence called the Fibonacci sequence, and characterized by the fact that every number after the first two is the sum of the two preceding ones. So here is a starting example of the sequence. As you can see, for example, the number 2 is can be obtained by summing the previous two. For the number 3 as well, we have the really simple formula for obtaining the Fibonacci sequence over here. Okay, and if you're interested in learning more about the Fibonacci sequence, you can take a look at the entry in a more detailed fashion. Okay, so let's say we have the first couple of numbers, and again our task is to create a model that tries to predict what the next Fibonacci number is given the previous one. Today we're going to use a really simple model called Simple Linear Regression. This model is very basic, and it has one main assumption. That assumption is that if you have two variables called x and y, there is a linear relationship between them. What that means is that your model is, as you can see from the picture in this red line over here, your model is just basically a straight line. The training process itself for our model looks really similar to what this image shows us, and we're going to take a look at how to create a model and train it similar to what is happening in this picture using TensorFlow.JS. The equation that describes the model is really simple as well, and you can see it over here. I'll zoom in a bit. So y is equal to a times x plus b, where the a parameter over here is called the slope and b is called the intercept. A and b are parameters for our model, and our task is to create a model or to create a procedure that finds those parameters for our model. Okay, so what is TensorFlow.JS? TensorFlow.JS is a library that extends somewhat from the TensorFlow library itself. For those of you who've never heard of TensorFlow, let's open their site. And the official slogan of the library says an open source machine learning framework for everyone. As you can see, the latest version of TensorFlow, the original library, is 1.8, and if you go to GitHub, since TensorFlow is open source library, you can see there is a release candidate 1 pushed 7 days ago, and you can maybe try to use it in your own projects. The main difference between TensorFlow and TensorFlow.JS is the language that you're going to use when creating your models. Your models in the original TensorFlow library are created using Python or maybe C or C++. And the as the name suggests, the TensorFlow.JS library allows you to create models that are written in JavaScript and can be run on the browser or on Node.js. So you can run them in the browser or in the server using Node.js. The cool thing about this library is that you don't need anything special to run it. You can just create an HTML file, JavaScript file, write some script in the JavaScript file, and train and deploy your model everywhere where browser or JavaScript runtime is available. So that means that you can create your models and train them in a mobile environment, so you can use Android or iOS and build and train and run models over there. You can use Raspberry Pi or any other operating system, or pretty much everything that runs JavaScript. So this is really cool. The installation is really simple, and we're going to take a look at how to install actually TensorFlow.js right now. As I've already said, the installation is really simple. You just have to create an index.html file. For that, I'm going to go into my favorite editor. I have an empty folder in here, and I'm going to create a new file called index.html, and I'm going to try to zoom in, but I'm not sure I'll be able to do it. Yeah, maybe not. Okay, the HTML file I'm going to paste is HTML5 file, and it contains a script entry that is pointing to TensorFlow.js, to the latest version of TensorFlow.js. And the other entry is an entry to our own index.js file, in which we're going to write our model that predicts the next Fibonacci number. Okay, let's save this, and I'm going to create our script file. And in that file, we're going to put everything we're going to use right now in order to create our model. So the first thing I'm going to take a look right now is what is a tensor. As the name of the library suggests, tensors must be really important because the library is called after them. So let's create our first tensor. Okay, I'm going to enter in insert mode and create a variable that says, actually I'm going to create a constant that says my first tensor, and we're going to use the TensorFlow.js library and create our first tensor. Okay, that's our first tensor, and as the name of the function that we're going for from TensorFlow.js suggests, that tensor is a scalar. What that means is just a simple number. Okay, and we're going to use console log to print the value of our tensor. Okay, to run this, you have to open your index.html file, so I'm going to do that right now. Okay, so I'm going to have to open it from files, and as you can see, there is nothing on the screen, so you have to go to inspect console, and you're going to see something really strange. The output from the console is some strange object with a bizarre structure that you might not understand from the beginning, but if you have to really print the value of your tensor, you have to use something else. So I'm going to remove that, and I'm going to use my first tensor dot print method. If I go back to the browser and I hit refresh, we're going to see that the tensor value now is 42, which is great. You can now print tensors values, and it looks like it's really hard to just print numbers or values of tensors in TensorFlow. That's like really strange, but now that you know how to do this, you can kind of feel that you have like superpowers or something. Okay, so that was our first tensor, and let's create a second tensor that is actually a vector. In this vector, which we're going to call one-dimensional tensor, tensor 1D. In it, we're going to pass an array of three numbers 1 to 3, and we're going to print the value of it. If I go back to the browser, you can see that our previous tensor value is still here, and you can see that the second tensor, actually our vector, is containing now the values 1, 2, 3. So what is a tensor? A tensor is just a holder for numbers. It can be of an arbitrary large dimensions, including 0 dimensions, which is the scalar value that we've already seen. And it can be like a vector or a matrix or any n-dimensional thingy you want to hold numbers in. So, okay, the tensors are just our data holders. The data holders, we need them because obviously when we do machine learning, we're going to use a large number of data rows or database or anything, and in order to create a model that is recognizable by TensorFlow, you're going to have to somehow transform the data into tensors, so TensorFlow can like really operate on it and apply some operations to it. Okay, so as we've already discussed, we're going to need some training data. And to do that, we're going to actually generate the Fibonacci sequence. Once again, the Fibonacci sequence is really easy to generate. You just have to sum the previous two numbers, as the formula over here suggests. Note that this is a recurrent formula, so it is a recurrence. And it's like really easy to code this recurrence into JavaScript, but it is somewhat inefficient. So we're going to take a different approach. We're going to actually generate an iterative version of it, and I'm going to just take this function over here, which is called Fibonacci, that accepts a num parameter, and I'm going to paste that into our index.js file, and we're going to have a somewhat deeper look into it. We're generating two numbers, a and b, and another parameter temp, and on the second line we're generating a sequence parameter, sequence variable that is going to hold actually the Fibonacci sequence that we are going to generate. So let's pretend that we've passed the number 1 over here, and we're going to start a for loop as long as the number is greater than 0, so 1 is greater than 0. We're going to hold a reference to the current a value. We're going to see why in a minute, and we're going to apply actually the Fibonacci sequence formula over here. We're going to just sum a and b. Then the number b is going to be the previous a value using the temp version, and actually the number b is the Fibonacci number we're going to push into our sequence holder, and then we're going to decrement the number by 1. So then our number was 1. Now it is 0. Is 0 greater than 0? No. So we're going to return the sequence for the first number, and since the initial value for a was 1, and remember that we over here over here set temp equal to a, which is 1, and then b is equal to temp, which is again 1. We are only pushing the number 1 into the sequence, so the first number of the Fibonacci sequence using calling this function is going to be 1, and that's the whole sequence. You can follow the same process for the second number, third number, etc., etc. Okay, so we have that Fibonacci function over here, and we're going to actually generate the first 100 numbers using it. Okay, we're just calling the function, 100 numbers. We're just calling the function, and the result of it is going to be holding this constant fibs. So if I go to the browser again and hit a refresh and just call the fibs variable, you can see that we have 1, 1, 2, 3, etc., etc., etc. And it looks like the Fibonacci sequence is growing pretty fast, even though it has a really simple formula. As you can see, the 100 number, which is like that one, is really large. Okay, so you can have a lot of fun with this function, I guess. But we're going to use that array to generate our training data. The next thing we're going to do is actually create that training data. And for that, I'm going to create another constant, which we're going to call axis. Again, that notation that I'm going to use is based on the fact that our formula for the linear regression over here is based on x's and y's. So x is going to be our data that we're going to create right now, and y is going to be the number that we're going to have to predict given that x number. So let's say that I'm giving the number 2, and that's the value of the x over here. When our model is trained, it will have to predict that y is equal to 3. So again, we're going for this number and predicting the next, which is 3 over here. Okay, and hopefully our model will be good enough to predict that. Okay, so the tensors, that data we're going to convert using the function that we've already used. It's tensor1d, since the Fibonacci sequence is actually a vector or one-dimensional tensor, whatever you want to call it. And we're going to do something a bit strange maybe for some of you, but we're going to just, I'm sorry about that, what's happening? Okay, what we're going to do is actually get only the first 99 numbers of the sequence, because we're again generating a training data. The training data must be in the following form. For each number x, there has to be a next number that our model have to predict. So if we start, if you get the sequence 1, 1, 2, 3, 5, which is the first couple of Fibonacci numbers, the y values for them must be 1, 2, 3, 5, 8. So this is the correct answers, and this is the data that we're going to use for training our model. So essentially we're just removing the last number from the fibs, and for y we're just shifting or dropping the first number from the fibs. Okay, so we have the tensor x's and y, and now we're going to create the y's tensor, and again we're going to just drop the first number using the slice function or method of the array object that we have. Okay, now we're going to actually apply a simple transformation to our data. We're going to scale it. So what that means is we're going to make that every number from that array are in the range of 0 to 1. And we're going to do that using a really simple operation. We're going to take the minimum value, which is 1. We're going to take the maximum value, which is this number over here, and we're going to subtract the minimum value from the maximum value, which is going to be this number minus 1. And then we're going to take each number, subtract the minimum value, which is again 1, and divide by the number over here minus 1. Okay, so I'm going to write the code for this, and maybe it will become a bit more clear. Again, taking the minimum value, the maximum value from the x values, and taking that number, which is the maximum value, minus the minimum value. As you can see, I'm using the method sub or subtract. Since we're having tensors over here, we're not going to be able to use just minus or something like that, and we're already using some of the TensorFlow methods. And we're going to create a function which is going to be called norm from normalize, and that function is going to accept a number, it's going to accept a tensor, and for that tensor, from that tensor is going to subtract the minimum value and divide that by the number that is, once again, that number minus 1. So essentially we're dividing every number in the sequence by this number minus 1. And the result of that applied to our x's and applied to our y's. We're going to refresh again the browser over here, and again, if we see our x's, you're going to see that the numbers are really large. But if you take a look at the normalized values, you're going to see that the maximum value over here is actually 1. There is another trick you can use. We can call the function datasync, and you can call the method datasync, and this method actually is going to return as a simple float 32 array the values of the tensors that you have. So you can inspect this just as you would like a kind of a normal array over here, and you can see that the first couple of values are like really small, and then the numbers are starting to grow rapidly, and finally they hit the 99 number, which is 1. You can kind of do the same thing for for our y values. And the cool thing about the y values is that it again starts at 0, but the maximum value is not 1, it's 1.61. That comes from the fact that we've divided divided our y's values by, again, the minimum values of the x values. So our y's are normalized based on our x's, if that makes any sense. So again, the maximum value is 1.61 over here. Why that is so? Why do we do it this way instead of just using the minimum value for each tensor? Maybe you can try to do that, to actually move this in here and try to run it this way, and you have to change the variable naming, etc. over here, and see your results when training the model that we're going to build right now, and compare it with mine. Okay, so it's time to really create our model over here. I'm just going to put some empty lines so it's easier for us to see what's happening. Again, our model is going to be represented by two parameters, or it's going to have two parameters. For that, we're going to create to use a new concept for from TensorFlow, and that concept is called variable. You see, the thing about the tensors is that they are immutable. So you once they're created, you can't change their values. You can only create new tensors from them. So when you are applying an operation such as subtract or min or max or divide or anything of that, you are actually creating a new tensor. And our parameters a and b are a bit special. They have to change so that during the training process the parameters must be getting better and better, and their values actually must be changing. So TensorFlow allows us to create this special holder called a variable, which actually allows us to easily change the value of this variable that we are having over here. So we're going to create our second parameter, b, and actually the parameters for our models are there, or at least their initial values are just that. Why we're initializing our parameters with random and not with something like 0 or some predefined number? Okay, so that's maybe a good question for you to discover on your own. Write back down in the comments what you found, and maybe just try to put zeros over here and see what happens when you train the model that we're going to create right now. Okay, so if I go to our console, once again hit refresh and print the value of A and print the value of B, you're going to see two numbers. Take a note that these numbers are going to be a bit different from yours, because if I hit refresh again and print, I'm going to see a different numbers. That's just because we have random over here. Okay, so first thing we're going to do is actually create our model, or the function that is going to apply our model. If we go back to our model, we're going to see that linear regression once again is just a times x plus b. So let's create that function in TensorFlow that, given some data x, is going to predict the number, is going to predict y, or actually y, or in our case the next Fibonacci number. What is this thing TF tidy? I'm not going to discuss this right now, but it's actually a very handy helper for when you're training your TensorFlow models on the GPU. So it's a kind of do the house cleaning thing to free up some memory from your GPU when training your models. And it's just like a good practice to put it over here. So we're going to do that in the case that you are using TensorFlow.JS using CUDA, which we're going to, again, not discuss right now, but that's a really great option if you have a powerful GPU. Not for this model. This model is going to be like really simple, really easy to use. So the model itself is going to be a times x, and we're going to just add b. So the syntax in TensorFlow is again a bit crappy, and we're going to use the multiply function and the add function. Okay, and that's it. It's like really that simple to create this model, to actually translate this model to the TensorFlow model we're going to have over here. The next thing we're going to need is actually a loss function. The loss function is going to be used for like evaluating how good our predictions from the model are. So actually, essentially, if you go back to the picture over here, at the start, when the line is like over here, our model is like really bad at predicting values from this dataset. And as the iterations or the time progresses during our training, you can see that the model is kind of learning the good parameters, so that the line actually is like right between in these points. So initially we're going to have to have something that tells our model, no, you're pretty bad right now, try something else. And our model is going, or our process is trying to, our training process is trying to learn good parameters A and B. It's going to try something else. So let's say that the first A and B parameters are like 0.1 and 0.1, and when fitted the line is like over here at the bottom of this. So okay, our model or our training process tells us, okay, try with 0.5 and 0.5, and then the line suddenly comes over here. And we have, okay, now, and we have something that tells us, okay, now that's a bit better, can you try something else still? And then the process tells us, okay, try these new parameters, and suddenly the line fits very, very well this training data. So the thing that tells us how good actually our fit is, or how good that line explains the data around it, is usually called a loss function or error function. Today we're going to use a really simple one. It's called the mean squared error. As the name suggests, the function actually takes each true value from y, and from that it subtracts the value that our model is predicting for the same data. Okay, so that is summed and divided by the number of training examples n that we're going to have. In our case, the training examples, actually n is 99 numbers, so this summation is going to contain 99 numbers in here. So yeah, the MSA actually measures the average squared difference between the predicted and real values. That should suggest to you that the number, the result obtained by the mean squared error cannot be a negative number. It can be 0, and the closer to 0 the better, but in practice that's like rarely the case, especially in real world large models. Okay, so let's code this loss function into our script. We're going to call it just loss. It's going to take our predictions and our labels. Again, the predictions are the output from the predict function, and the labels are just the real values that is obtained from y's we have over here. So using the formula over here, we're going to subtract the real values from the predictions. So we're going to flip this around actually, square it, apply this, and finally take the mean value from it, so divide by n. Actually sum and divide by n. So that's our loss function written in TensorFlow.JS. It's like really simple again to code this into this. The next thing is actually our training process, to create our training process. The training process itself is driven by something called an optimizer. The optimizer's job is actually to find good parameters for our model. Again, our model has two parameters, a and b, and the optimizer's job is to find good parameters that that explain our data as closely as possible, using just a straight line. Creating an optimizer in TensorFlow.JS is like really simple, and our optimizer is going to have single parameter. I'm going to talk about it in just a bit. The name of our optimizer is SGD. That's from stochastic gradient descent. We're going to maybe take a look at stochastic gradient descent and other optimizers in some of the next videos. But for now, we're going to just pass in the learning rate parameter, which is 0.5, which is a number that, if you're wondering how can we obtain this number or what good values for here are, well, currently it's like somewhat dark magic to find this number, although there are some even simple ways to find good values for this. But for the purposes of this tutorial, we're just going to put 0.5 and like forget about it. Okay, so we have our optimizer. You can see that the optimizer is from like a namespace or module in TensorFlow called train, and we just create an object using the SGD function. Okay, so we have like every ingredient we need, or every component we need to actually train a model. So let's write our training loop. We're going to actually say how much iterations, for how long or how much iterations our optimizer is going to use to find good parameters for our model. As you can see in the picture over here, the number of iterations needed to fit this line over here were 28 or 30 or something. And for us, it's going to be a bit more. We're going to use 10,000 iterations, and we're going to record the error for each iteration into an array. So the loop itself is going to be pretty basic, nothing that you haven't done already. The first thing we're going to do is call the optimizer. The optimizer has a method called optimize, which accepts a lambda, and the lambda itself must return the error for the current iteration from our model. Okay, so let's call our model using the predict function, and we're going to pass in the x values we've created already. Then we're going to score our model, or call the loss function that we've already defined above, using the predictions from our model and the real values, or the labels. We're going to actually save our error, and we're going to use the data sync method, so we can get just the value of it and return the error to the optimizer, so that our optimizer knows how well our model is performing at the current iteration, and try to actually find better parameters for it. Okay, so if we go to the no, we're actually going to stay like over here. The first thing after the training that we're going to take a look at are the errors. We're going to take a look at the error at the first iteration, and we're going to take a look at the errors at the last iteration. Okay, so now we can go to the browser, hit refresh. So I have an error over here. Oh, okay, I see. Sorry guys, I forgot to add the curly braces to our lambda function over here. And oh, I'm sorry, the function over here is not called optimize, it is called minimize. Okay, so yeah, that makes sense, since our optimizer is trying to minimize the error. Once again, error closer to 0 is always better. Okay, so you can see that your browser is like kind of thinking or something. Still training, I guess. Wow, that takes a lot of time. I expected this to be like a lot faster. Okay, another error. Actually, in the name of the error. Okay, go back and hit refresh and wait for the training process to complete. I have no idea why it is so slow to train this. Maybe because I'm recording this video, I don't know, but my PC is like pretty beefed up. We're going to wait and see. Okay, So the errors at the first iteration and the last iterations are like pretty different. You can see that at first the error is some small number, but like not anything we would like it to be, and the number over here is like really small, really close to 0, as you can see. Okay, so our errors are like pretty small, which is good. And the next thing we're going to actually do is use our model for prediction. We're going to pass two numbers that belong to the Fibonacci sequence. The first number is going to be like, let's say, 2, and the next number is going to be our last number in the X. In the X data that we have. So it's going to be this. Yeah, let's make this number. Let's try to predict this number. Oh no, I'm sorry. Let's. We already have this number answer in the Y, so our model has already seen the correct answer for this number. Let's take the Y's and the last number from the Y's is actually not present in the X's, so our model has never seen the answer for this number. It has seen the answer for 2, which is 3, but for this number it hasn't seen the correct answer, and we're going to call the predict function on that. Hit print and go and refresh. I'm going to some place to find a sequence generator for Fibonacci numbers, and I want to find the correct answer for this number that we've used over here, 35 something. So the 101. Yeah. Okay, so this is the correct result over here. I'm going to paste it. So the correct results should be 3 and this number 5, 7, 3, 1, 4, 7, etc., etc. And the results from our model are 3.23. Again, the Fibonacci numbers are just integers, but obviously our model haven't catch that, at least not very well. And the next number is actually an integer for that large number that we have over here. And I'm just going to copy this and try to actually compare it. As you can see, the first 5 digits are exactly the same, and after that we have a bit of a difference, but I would say that the result is like pretty good for just like a simple model in TensorFlow that you can write in 5 minutes or something. Okay, so yeah, again, the results are very good. The last thing I'm going to do is actually print the values of our parameters A and B, and to do that I'm going to just print their values. Yeah. Again, we're going to have to wait for training to complete. I might have done this just right here in the console, but I guess that's not cool or something. Okay, still waiting, and here we go. The parameter A, so I'm just still going to do that. For A, we have 1.618 something, and the number that you're going to receive might differ a bit, but it has to be pretty close to this. And for B, we have this a really small number. From that, you can see that the A parameter is actually the parameter that does the heavy lifting. So the A parameter is the really important one, and the B parameter is something that just had to be learned, but it might not have it might not have any importance or any weight when taking a decision about predicting the next number. Okay, so with that we are just done for today. You can find the source code in GitHub. I'm going to put link down in the videos, and I'm going to put a link to my blog which describes in maybe in better detail everything we've already talked about. We have a GitHub link to that same repo over here, and if I'm going to open it, yep, and we have a live demo of the model training in your browser, and when it's done, you have to right click and open the console to see the results. Okay, let's see if I'm missing something. Yeah, at the end of the blog post, you can see the whole gist of the source code that we've written together. And yeah, if we go to the demo, open the console, you can see some errors, but I think it's favicon or something. Actually, you can see that the model is trained, and the numbers you're going to receive for 2 and 3, the predicted numbers are correct, and the parameters A and B are also in here. Okay, so I'm going to put that down below. Thanks, and we'll see you next time.